Okay, question 3. The cubic polynomial fx is such that the roots of fx equals to 0 are minus 1, 1, and k. So usually when we solve, we will get the answer, okay? Like x equals to minus 2, or x equals to 1, or x equals to k. So we are working back to find the equation. So if I were to work back, right? So I were to work back one more step. If I were to work back one more step. Okay, wait, so now let's say when we work back, when we work back a bit, we will actually get x plus 2, x minus 1, x minus k equals to 0. Correct? No? But in actual fact, the question did not ask that what is the coefficient of the x cube for this x cube. So we have to assume that there might be 1, it might be something else. So it can be a bracket x plus 2, x minus 1, x minus k equals to 0. So if I divide it at this step, remember, if I divided both sides by a, it will end up with the next step here, right? So the a itself is just the coefficient of the x cube. Okay, we do not know. The question did not tell us. Sometimes the question will tell us, but at this moment the question did not tell us. So we have to assume this. So in actual fact, the polynomial, okay, of this is actually a bracket x plus 2, okay, x minus 1, and x minus k. So it's given that fx has a remainder of minus 24 when divided by x, and a remainder of minus 18 when divided by x plus 1. Okay, so this part here looks a bit confusing by when I talk about this. Fx has a remainder when divided by x. But if I were to look at the other one, now, the remainder of 18 when divided by x plus 1. If it's okay, let's say I do the orange color one. If I do the orange color one first. So if I were to write, if I sub in as minus 1, it will be equals to minus 18, correct? No? So now I were to sub in a minus 1 plus 2 minus 1 minus 1 minus 1 minus k equals to negative 18. Okay? So now I will get a bracket 1 minus 2. Then I will have minus 1 minus k equals to negative 18. Alright? Therefore, bracket a, okay, divided both sides by this negative 2 here. Okay, I will have bracket minus 1 minus k equals to 9 here now. Okay? Okay, I want to take note of something. This is x plus 1. So I will put it as, when I substitute here as the x, right, it will be x equals to minus 1. So when it's divided by x, right, this part here is actually x. Okay, plus or minus doesn't matter. So maybe I put plus 0. So the issue now is I am actually substituting x equals to 0 to give you a remainder of minus 24. So there are two things here now. Okay, so let me separate out first. Okay, so x, when I sub in 0 for the polynomial, so a 0 plus 2, 0 minus 1, 0 minus k is equals to negative 24. So as I open up, here this will only left with 2, minus 1, and minus k. So multiply together, it will be 2ak equals to negative 24. Divided both sides by 2, ak is equals to negative 12. A will be equals to negative 12 over k. So I need to, because there are two unknown, so there are two equations now. I just need to sub in my number 2, my number 1 into my number 2. So I'm substituting a as minus 12k now. Minus 12 over k, bracket minus 1 minus k equals to 9. Okay, I need to multiply both sides by k. So this one balance the equation. So minus 12 minus 1 minus k equals to 9k. So now I need to expand in 12 plus 12k equals to 9k. Okay, manipulate the equation here. Here will get 3k equals to minus 12. K will be equals to minus 4. Once I know k equals to minus 4, I can sub in here already, right? So a will be equals to minus 12 minus 4. Okay, a will be equals to 3. Okay, please do not write equals here. Okay, one equation only got one equal. Okay, one line there's only one equal. So I have k equals to, I have my k equals to minus 4 and a equals to 3. That's the answer.